Okay, and a solute is what gets dissolved. So that is the substance that gets dissolved. And I want you to think of salt water. And if you have salt water, what would the solute be? It would be the salt, right? And then the solvent is going to be the water. So the solvent is the substance that is doing the dissolving. All right? So I want you guys to think about what is dissolving? How is that different than melting? Have you ever thought about, what is melting? Because I hear a lot of students will say, well, hey, what does the salt do in water? It melts in it. It does not melt in it. Melting is a phase change between a solid going to a liquid. Dissolving is when you've got these particles of water, and then you put in a glass or whatever, and then you put in the salt, and the salt fits into the particles between the water, and it all becomes one solution. All right, so that's what's happening when you dissolve one substance into another, is the smaller substance is fitting into those spaces between the particles. And so one substance is getting dissolved, and that's the solute getting dissolved in the solvent. So what is the difference between soluble and insoluble? Well, a soluble substance is two substances that are able to dissolve in each other. All right, so two substances that are able to dissolve. And insoluble are two substances that are not able to dissolve. All right, so not able to dissolve. And we'll get to that later when we talk about polar versus nonpolar. But basically what you'll see is things that are polar will dissolve in a polar solute will dissolve in a polar solvent. A nonpolar solute will dissolve in a nonpolar solvent, but a polar will not dissolve a nonpolar. So we call it the like dissolves like principle, and we'll get to that later. But that's as far as solubility, what gets dissolved in what. And you've seen that before, like oil and water will not dissolve in each other. Okay, well, oil is nonpolar and water is polar, and so they will not dissolve. So insoluble is not able to dissolve. Now, what about miscible versus immiscible? All right, miscible are two liquids that can be dissolved in each other. So this is two liquids that can be dissolved in each other. Excuse me. So two liquids that can dissolve in each other. All right, what about immiscible? You've heard that, if you're in court, oh, that's immiscible in court. What do? They throw it out, right? You're not able to use it in court. Well, that's not what we're talking about here, but it's a similar idea. It's two liquids that are not able to be dissolved. So two liquids that won't dissolve. All right, and so what are two liquids that can dissolve? Oil and water. That's two examples, mineral oil and water and stuff like that. Two liquids that are miscible is like fruit juice in water. Okay, that's what, if you drink Minute Maid fruit punch, which may be the greatest drink on the planet, okay, that is 10% fruit juice and in water, sugar. It's good stuff. You guys ever had that? It's really good. Okay, anyways, what is solvation? Okay, this is not talking about salvation. Okay, we can talk about that another time, but this is solvation. Now, solvation, okay, is when you have solid particles, okay, or you have particles of a solvent that surround a solid, okay, and basically rip it apart. So if I have like a sugar cube, and I put that sugar cube, and I put that sugar cube in water, what happens is all these little water particles get all excited and they surround that sugar cube, and basically they come in. It's like fire ants going to bite somebody. They all line up. Okay, this guy goes in, takes a chunk, and then gets out. This guy goes in, takes a chunk, and gets out. Okay, it's all these water particles. They surround the sugar cube, and they break it apart. Okay, so they're basically dissolving it. All right, So they come in, take a chunk, leave. The next guy comes in, takes a chunk, and leaves until they break it all down. All right, and that's called solvation. All right, it's basically dissolving. It's a dissolving process done by the solvent surrounds the solid and takes it apart. All right, so our next thing is, what are the factors that affect dissolving? All right, so these factors that affect dissolving, the first one is you grind up the solute. That will make it dissolve faster, okay? So if you take a sugar cube and just put it in a glass of water, or if you break that sugar cube up, you grind it up and then sprinkle it in the water, okay? You're increasing the surface area. You're increasing the surface area that's getting broken down. And the more solute particles that interact with solvent particles will make it dissolve faster. So basically, by grinding up the solute, you're increasing particle interaction. Well, the more particles of sugar that are hitting water, the quicker it's going to dissolve. All right, so that makes sense. So you're increasing particle interaction. The second one is shaking or stirring, which is called agitation. Agitation. All right, so that's shaking or stirring. All right, I've chaperoned a lot of dances at Coppell High School, and there's a lot of shaking going on, or some people are stirring it up, right? Either way, you're increasing particle interaction. You're on the dance floor, you're increasing interaction, all right? And so that will get more dissolving to happen, okay? When you do orange juice, okay, you guys in Coppell buy really freshly squeezed stuff, but I'm saying if you're in the ghetto, okay, like me, you go to the store and you buy the 99-cent frozen one, you get it, you put it in the container, and it comes out in the big clump, and then you got to add 2 quarts of water, and then you can either shake it or you can stir it, but you got to dissolve that big clump of orange juice in the container, all right? So some people like to shake it, that gets the bubbles on it, okay? You shake the juice up, give a little foam on the top, nice. And some people like to stir it just to mix it up, okay? Whatever makes you happy. All right, so we've got grinding up the solute, that increases the surface area, that increases particle interaction. So agitation, which is shaking or stirring, okay, increases particle interaction. So we've got grinding, shaking, and stirring. It's already got Jack's attention. Okay, so now, the other one is increasing the temperature. Okay, so if you increase the temperature of a solid in a liquid, so of a solid in a liquid solution. So if I raise the temperature of the liquid, I will be able to fit more solid in. Now, how does that go hand in hand with what we've been talking about with particles? If I increase the temperature, what are the particles going to do? Are they going to move faster or slower? If you increase the temperature. Faster, right? And so if they're moving faster, they're going to create more spaces between them. If there's more space, the particles can fit in easier, right? So it'll increase the dissolving rate. So increasing the temperature of a solid in a liquid. Now, if I'm talking about a liquid in a gas, it's the opposite. So decreasing the temperature of a liquid in a gas. All right? So we call it the 2-liter principle, right? If you want to, you go to a party or whatever and you're drinking a 2-liter, what's the worst thing about 2 liters? They lose their fizz, right? I mean, they're out there, okay, next day, it's like you just got to throw them away because they've already lost their fizz. Well, how do you keep the fizz in a 2-liter? You first put the lid on, and then you put it in the fridge because you'll fit more gas, and more gas will stay in the liquid in a colder liquid, okay? And more gas will stay in the liquid if the lid is on to keep the pressure high. Because what happens when you open the 2-liter bottle, okay, what happens? The air is going to leave. It's going to reach equilibrium until there's no fizz left. But if you put the lid on the bottle, you got to be careful drawing bottles on the board with lids. Then it keeps the pressure inside the container, okay, at a higher pressure, and it's able to keep the gas in. All right, so 2-liter principle. To keep the gas in the liquid, put it in the fridge, right? and keep the lid on. All right. The other way to remember is to increase. Oh, we'll talk about it later. But either way, that's another day. Okay, but increase the temperature of a solid or liquid. Okay, that increases the dissolving rate. Decrease the temperature of a liquid and gas. You got to know the difference between those. All right. Now the next term is solubility. All right, solubility is how many grams of solute I can dissolve in a set amount of solvent. So what do you mean a set amount? Well, usually they say in 100 grams of solvent. So that's the typical one that's used. So they're usually going to say 100 grams of solvent, whether that's water, whether that's whatever solvent you're using. Water is the universal solvent, so it gets used a lot as solvent. So how many grams of solute I can dissolve in a set amount of solvent? Well, there's 3 different ways to describe solutions with solubility. There's unsaturated. In an unsaturated solution, I can fit more solute in. Okay? So it'd be like if you said you're making Kool-Aid, all right, and it says add a cup of sugar, all right, and I only added a half cup of sugar. Well, can I add more sugar? Will more sugar fit in that solution? Yes, it will. So that is a solution in which more solute could be added. All right, more solute could be added. So the solution can take more. A saturated solution means the maximum amount of solute has been added. All right, so maximum amount of solute has been added. So it can't fit anymore. All right, if you put any more solute in that thing, it's gonna settle to the bottom. It can't. There's no more room in the solvent to fit any more solute. All right. So supersaturated is a solution in which solvent has been added past the saturation point. Okay. So a supersaturated solution is solute has been added past the saturation point. Now, in most supersaturated solutions, what they do is they add a whole bunch of solute, heat it up, because you can add more solute if the temperature gets hotter, stir it in, stir it in, stir it in, and then they cool the solution. So if they do that, then there's actually more solute than that solution can handle. And so one more little crystal added in will make a whole bunch of it settle out. It's kind of cool. We're going to do that in lab on Friday. All right, so that's supersaturated. So unsaturated, more solute can be added. Saturated, maximum amount of solute has been added. Supersaturated is a solute has been added past the saturation.